Diagram shows the graph of y equals x plus 2 all squared, 1 minus 3x. The curve has a minimum at the point A, a maximum at the point B, and intersects the y-axis and the x-axis at the point C and D as shown. We want to find the x-coordinate of A and the x-coordinate of B, and those are the turning points. So that's going to be the points where the gradient is 0. So we can actually differentiate this expression, and that's going to involve the product rule. So we can say, well, u is x plus 2 all squared, and v is 1 minus 3x. And then du dx, so we're going to use the chain rule here, 2 drops down, 2x plus 2 to the power 1, multiplied by the differential of the inside, but the differential of the inside in this case is just 1. And then dv dx is going to be negative 3. So dy dx is going to be v du dx, so that's going to be twice x plus 2, 1 minus 3x, plus u dv dx, so that's a minus 3 there, so that would be minus 3x plus 2 all squared. And if I go and look for values where this is 0, it might be an idea to factorize here. So I've got a common factor of x plus 2 that I can pull out. Then I've got twice 1 minus 3x to complete the first term. Take away 3x plus 2 to complete the second term. So that's x plus 2 into 2 minus 6x minus 3x minus 6. So that's x plus 2, and then I've got minus 9x, take away 4. And so I can write that as, let's just change that a second, minus x plus 2, 9x plus 4. So for dy dx to be equal to 0, that means that x is equal to negative 2 or negative 4/9. We now want the coordinates of C and of D. Well, C is on the y-axis, and that means x equals 0. So our expression was y equals x plus 2 all squared, 1 minus 3x. So the y-intercept is when x is equal to 0. So that means y would be 2 squared times 1, which is equal to 4. So C, I think C was where it cuts the y-axis, yep, is the point 0, 4. And then D is the x-intercept, and that means that y is equal to 0. So we've got x plus 2 all squared, 1 minus 3x equals 0, which gives us x is negative 2, or x equals 1/3. And the negative 2 is actually the double root here at A, so it must be at 1/3. So D is the point 1/3, 0. So we want the area now of the shaded region. So that's this region just here, which is the area under the curve from x equals 0 to x equals 1/3. So we're going to have the integral from 0 to 1/3 of x plus 2 all squared, 1 minus 3x. Okay, I think I'm going to have to expand this out. So we've got 0 to 1/3. So that's going to give me x squared plus 4x plus 4. I don't know why I put an equal sign in there. And 1 minus 3x. that's the integral from 0 to 1/3 of x squared plus 4x plus 4, take away 3x cubed, take away 12x squared, take away 12x. So that's the integral from 0 to 1/3 of minus 3x cubed. Now with the x squareds, I've got to collect the like terms, so I've got minus 11x squared, so that's from there and there. Then with the x's, I've got an x here and I've got an x there, so that's going to give me minus 8x. And then I've got the constant, which is plus 4. So we've got minus 3x to the 4 over 4. Take away 11x cubed over 3. Take away 8x squared over 2, which is just 4x squared, add 4x. And that's going from 0 to 1/3. And actually, only the 1/3 is actually going to give us a value here. So we've got negative 3 times 1/3 to the 4 over 4. Take away 11 times 1/3 cubed over 3. Take away 4 times 1/3 squared, add 4/3. Okay, let's do some calculation. So 1/3 to the 4 is 1 over 81, and we're multiplying that by negative 3 and dividing it by 4. That's negative 1 over 108. And then we've got a third cubed, which is 1 over 27, and we're multiplying that by 11 and dividing by 3, which is 11 over 81, and then this one's just going to be 4/9, add 4/3. So we've got 4/3, take away 4/9, take away 11 over 81, take away 1 over 108. That's 241 over 324 square units. And as a decimal approximation, that's about 0.74.